And welcome back, Wolfpack. Thank you for being a part of 5.2, Properties of Circles. Our essential question is, how do you find the measure of an angle within a circle according to its position? This first section is a lot of vocabulary, so I hope that you are prepared. Some of these terms you have heard before, some of them may be new. If you have any questions, please make sure you are writing it in the margins. A chord is a segment whose endpoints are on the circle. Example of a chord would be BA. B to A, the line is in the circle and its endpoints are on the circle. We have a special type of chord called the diameter. And the diameter is a chord that contains the center of a circle. So if it starts on one side of the circle, such as B, goes through the center to the other side, that's a chord as well, but it goes through the center of a circle. A central angle is an angle whose vertex is the center of the circle. So an example of a central angle would be angle ACD. Sorry, my smartboard is just being totally wonderful. ACD is a central angle because its vertex is at the center. The vertex of that angle is at point C. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So I'm going to erase to show you better what an inscribed angle looks like. Inscribed angle, the vertex is on the circle, such as B, and the sides of the angle are chords. So ABD, angle ABD, is an inscribed angle. Now we're going to talk about arcs. We have two words, minor and major. A minor arc is part of a circle measuring less than 180 degrees. So, and it's usually named with two letters. And a major arc is part of a circle that measures between 180 degrees and 360 degrees. And its name is normally named with three letters. You'll see an example of this in a moment. So for example, AB would be a minor arc because it's less than 180 degrees. And a DB would be a major arc because it's more than 180 degrees. Then we have a semicircle, and a semicircle is an arc with endpoints that are endpoints of a diameter, and the measure of a semicircle is always 180 degrees. And if you look at our example, ADB, that's a semicircle because the endpoints are the endpoints of a diameter. The measure of a minor arc is the measure of its central angle, which is how I knew this angle right here is 50 degrees, angle ACB. That means the arc is also 50 degrees. The central angle is 50 degrees, the minor arc is 50 degrees. The measure of an entire circle, you should be comfortable with that, is 360 degrees. So from A to D to B, all the way back to A, is 360 degrees. And that should be something that you should already know. And the measure of a major arc is 360 minus the measure of the related minor arc. So we already know that AB is 50 degrees. Well, I can find arc ADB, that red, by doing 360 minus 50. So the red arc ADB, is 310 degrees. 310 plus 50 is 360 degrees. Let's do a couple of example problems. Classify each given arc, then find each arc measure. So arc MN. So from M to N. Is that a major arc or is it a minor arc? Well, it's only two letters. And besides that, I already know what the measure is. But it is a minor arc because it's got two letters. I see that it is a vertical angle with this angle. And since the angle is 73 degrees and it's a central angle, the arc is 73 degrees. So it's a minor arc, and it's equal to 73 degrees. Arc MNR. M to N to R. This is a major arc. You go in the direction of the letters. You can see it covers more than half the circle, 3 letters. And we're going to figure out the measure of the arc. So, I know an entire circle is 360 degrees. We're going to have to do this a couple of different ways. This is a diameter, which means this blue, should have gotten a little bit better, there we go. That blue, let me undo that, give me a second. Okay, this blue is 180 degrees. Well, if I know the blue is 180 degrees, and I know this part is 73 degrees, that means the rest of this is 107 degrees. Right? So we know the whole blue made 180 because it's a semicircle. I already solved for MN the last problem at 73 degrees. So that means MR is 107 degrees. So if I am looking for all of this green, all the way from M to N to R, I'm going to take 360, and I'm going to subtract 107, which is this portion right here. And when you get that, 360 minus 107, you get 253 degrees. So the measure of arc MNR is 253 degrees. We will do the next 3 together in class. Next page. The inscribed angle theorem. The measure of an inscribed angle is half the measure of an intercepted arc. So central angles equal the arc, inscribed angles are half of the arc. And if 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. They are the same. That means angle A is congruent to angle B. If you notice, angle A, it intercepts this arc, and angle B intercepts this arc. Since they intercept the same arc, the 2 angles are congruent to each other. So we're going to find the measure of some of the angles and arcs. The measure of angle RST. So RST. Well, we learned that the measure of an inscribed angle is half of the arc. So if the arc is 60 degrees, notice this is the arc it's intercepting. Half of 60 is 30 degrees. So the measure of angle RST is 30 degrees. Then we're going to look at the measure of arc QS. The measure of arc QS. That's the arc. The angle that's intercepting that arc is 37 degrees. So I'm not going to cut the arc in half, the angle in half to find the arc. I'm going to double the angle to find the arc. So 37 times 2 is 74 degrees. So the measure of arc QS is 74 degrees. And we will do C and D together in class for practice. Okay, as well as the rest of the notes. So please make sure you have looked over them. If you have any questions, please make notes in the margins. That way you can be prepared to ask me in class. If you want to try the practice problems before you come to class, go for it. And I hope you guys have a wonderful day. Talk to you later, Wolfpack.